Okay, hello everyone. Thank you for joining our webinar today. My name is Mary. I'm the Marketing Director here at BLiNQ Networks, and today I'm joined by Dan Stuart, our Systems Engineer, and Katie Heyl, our Account Executive. They will be discussing a number of use cases for private LTE and will be presenting some ideal solutions using BLiNQ. So at the point of registration, you would have been asked the question, what use case are you most interested in? And we received a wonderful mix of answers, including the ones we will be covering today. And now I'm just going to launch a quick poll for those of you who've joined us, just to gauge which use cases you're most interested in. So let me launch that now. One moment. Katie, are you seeing my poll?
I am not.
Oh, you're not. Okay. Let me do that again. Okay.
Oh, there it is.
Okay. So go ahead and place your votes. I'll leave this up for about half a minute just to get everyone's response. And I'll share the results with you in a moment. So I know a lot of people were interested in private LTE in general and the FWA use case. So it's just interesting to see what the popular answer is today. Okay, just a little longer. Just keep voting, guys. Okay, I will share it now. Looks like you guys are most interested in private LTE in general, so that's good. We'll definitely be covering the 5 main use cases during today's presentation. But just to quickly go over our agenda today, for those of you, for those new audience members, we'll provide a brief overview of BLiNQ and also of private LTE. And the 5 main use cases we'll be discussing are emergency response, education, tribal reservations, utilities and power companies, as well as mobile parks and campgrounds. And then we'll go into the BLiNQ solutions by use case. Finally, we'll wrap up with some Q&A. And then I do encourage you all to submit your questions during the presentation. We have a Q&A and chat box where you can type your questions in, and then we'll address them at the very end or throughout if we have some space to do that. So without delaying further, I'm going to hand it over to Katie to kick us off.
Awesome, thanks, Mary. So welcome everyone. A little bit about BLiNQ Networks. We are a leading LTE manufacturer of Cbrs certified hardware, and we are headquartered in Canada. We are pivotal in facilitating internet connectivity in hard to reach areas across the US and really globally. And with our FW300i solution that we have manufactured, we've made an easy, all integrated Cbrs ready network in a box that provides superior non-line of sight performance along with high capacity for operators. Our solution really honestly is very scalable and secure, and it makes it perfect for private LTE networks, which is what we'll be discussing in the following slides. So what is, sorry, go ahead.
Yeah, so this is Dan Stuart. I'm going to be going over an overview of private LTE. Just so you all know, this is not a technically deep presentation on private LTE. We have other webinars that we can do for those. So if you're interested in it, please leave those comments or leave us with those comments, and we can certainly put another more in-depth LTE, about LTE. So this is really just kind of a brief overview. LTE is basically the technology behind 4G. It stands for long-term evolution. It was a standard developed when 4G was designed for the purposes of phones and towers and other devices, basically to talk to each other. There was other standards like ultra mobile broadband that you know as UMB, and of course WiMAX. But LTE has become the global standard technology for cellular communications. Private LTE is basically that same standard, only scaled down to fit the needs of specific entities. Those can be industrial, automotive, manufacturing, utility, metering, logistics, smart cities, and I could literally go on and on. Pretty much everywhere you see a Wi-Fi enterprise deployment now is a good possibility for deploying LTE networks and private LTE networks. Let's put it that way. So 10 years ago, LTE was being deployed only by the tier 1 mobile network operators. Deploying private LTE solutions was really prohibitively complex and expensive. I worked for Ericsson for about 6 years, and I can tell you it could get very, very complicated. So the learning curve was really high and with a lot of detailed engineering requirements that really could overwhelm the traditional wireless WAN operator who's used to deploying Wi-Fi and Wi-Fi-like proprietary solutions. Also, for wireless ISPs, wireless spectrum availability was either unlicensed, operating the ISM, or the unibands 2.4 and 5 gigahertz, where constant interference issues were really the dominant issue surrounding that deployment. Or they got lucky and were able to operate in a license band. Those license bands were very scarce. Typically, they're owned by tier 1 operators and leasing companies. And a lot of these companies would actually sit on their license without even deploying, which was quite aggravating to the wireless ISP communities. So in the past 5 years, private LTE technology has become much more attractive as a result of economies of scale, right? As more and more LTE products are developed, the prices are going down on the chipsets, that sort of thing. So even the technology advancement in the EPC is the evolved packet core. The technology advancements have really reduced the learning curve to be much more in line with typical Wi-Fi deployments. As an example, I can just point you to Magma, which is Facebook's entry into the EPC world. So in addition to that, spectrum sharing in the form of Cbrs has been implemented by the FCC. It's now being deployed, literally hundreds of thousands now. CBSDs are being deployed throughout the US, and it allows use of PAL users, which are priority access license users, to be able to operate alongside the general authorized access. Basically, you got 150 megahertz, 70 megahertz of that is actually guaranteed for general availability, which is far greater than anything that they've had before. So with the advent of the SAS, which is the server access system that manages the licensing and the frequency use, basically it's really changing the dynamics of compared to the licensed band, or compared to the unlicensed band, where at 5 gigahertz and 2.4, it's really wild west. You can be up and operational for 2 years, and then all of a sudden somebody throws up a 5 gig and throws a hook into your network that you got to go out and troubleshoot. I'm sure those WISP that are out there are very familiar with those kind of problems, and they're ongoing. So with CBRS, that sort of thing is really taking much less of an issue that we're seeing. So that's about it right there. Let's go to the next slide. Yeah. So why is LTE the right choice? Many businesses have relied on Wi-Fi to meet many of those needs, but while Wi-Fi offers high value for the investment, it really falls short when compared to private LTE in terms of interference, security, configurability, upgradability, and scalability for business and industries with critical reliability needs. Just a few of those reasons, or the reasons why you might choose LTE. First one being capacity. Private LTE uses either dedicated or shared spectrum and really puts the customer in control of the infrastructure density based on their individual needs. With CBRS, interference issues are not as prevalent, as I spoke of before, as they are in the unlicensed band. Also, LTE is based on OFDMA in combination with other order modulations up to 64 QAM with large bandwidths up to 20 megahertz. And you can go even higher to 40 megahertz with 2 common carriers and spatial multiplexing 4x4. You can really reach very high data rates. The other thing, coverage. Private LTE in the 3.5 band offers much greater coverage and performance in non-line of sight and near line of sight conditions than traditional line of sight only 5 gigahertz bands. So while 5 gigahertz might go a little bit further in distance, as soon as you drop below into near line of sight or non-line of sight, it really ends up starting having issues where the 3.5 band actually works pretty decently in that band or in that scenario. So we already talked about spectrum availability, that being CBRS. I'll kind of skip that. With regards to reliability, LTE basically offers much better latency control, quality of service control, resiliency, and of course, security. From a security standpoint, SIMs are actually used in devices that have unique identifiers on the network, and they have to be properly authenticated. This again gives the network administrators much tighter control over what devices are allowed on the network. So with regards to future proofing, the move from 4G to 5G is different from past network upgrades. 5G isn't replacing 4G, like how 4G networks overtook 3G, but instead 5G is actually building on 4G LTE using updated radios and software. So right now, if you have a 5G phone and upload videos to Google Photos, you're actually using a 4G LTE connection for that uplink, no matter what the tier 1 providers want you to believe. So like anything else, 4G will become obsolete, but that day is far enough in the future that deployments today in the foreseeable future will be deployed on 4G network. And then finally, just a comment about interoperability. Since LTE with CBRS is standards-based, operators aren't locked into specific proprietary solutions. So they can take advantage of the multitude of devices, CBSDs and UE devices that are being added every day. You can see these if you go out to the OnGo, which is basically the WinForm certification site. New technologies are even further reducing the learning curve and the cost of deployment time for the LTE core. So these are all pretty much the primary reasons. There's a lot of other ones we can discuss, but those are really the primary reasons. Next slide.
Now, just to put this in, into perspective, so the private LTE market, it's projected will be worth over 13 billion by 2026. This growth really is attributed to the massive surge of connected devices that are going to generate the need for a secure and reliable communication between devices. And, with this growth, there's some, and like Dan had just kind of talked about with like Cbrs Alliance and all these new devices, it's not just the eNode Bs and the CPEs that are going to need to be connected, but a lot of end user devices that are going to be, that are growing. The list is going, the iPad, the iPhones, Samsung devices, the list is going, growing on and on and on, and they're all including this new, the band 48 in these devices. So it's just going to continue, at least, especially in the US market, the private, the private LTE market is going to grow. And this growth just won't be in telecommunications sectors, but it's going to be, we're going to start seeing a lot of it in education, which we we already are seeing this past year, enterprise, hospitality, public utilities, and, just to kind of name a few. And especially, with recent FCC auctions that we've seen, like the PAL 105 auction that concluded last year. I mean, actually, PALs are starting. I believe it might be today that PALs are going to start today. We've seen that, public utilities really are showing a great interest in private LTE because it really offers what they need, as well as being secure and reliable, which traditional Wi-Fi technologies, they did not have. So just, like we're all here, why are we here today? So here are some examples of some private LTE use cases that we'll be going through today. Fixed wireless access is probably one that is the most popular today, especially when considering internet service providers. We've made it, BLiNQ has made it easy to deploy solution for ISPs in rural and suburban areas and connect their customers that they really could not get connected with traditional Wi-Fi or proprietary technologies utilizing fixed wireless access. ISPs are able to deploy our fixed wireless access solution to build their own high-speed, reliable network, and while also filling coverage gaps that they had from either unlicensed line of sight only technologies and really just connecting those unconnected subscribers. So really it's an additional tool in the toolbox that ISPs can use for their fixed wireless access, utilizing Cbrs and getting customers that are either, that had non-line of sight, so they couldn't get with 5 gig or 2.4 line of sight only technologies. But, other than fixed wireless access, what about, there's plenty more use cases that can utilize private LTE to their benefit. The first that we're going to talk through will be public utilities and really talk about the challenges that they face and how does private LTE provide a solution to those challenges.
So public utilities really have been building their own communication networks for decades. So, enabling emergency response and service restoration, that's pretty much been a given, but they haven't been high speed or they haven't provided the high capacity necessary to do some of the other unique challenges there. Cbrs-enabled utilities can combat fault in real time through remote monitoring and control, as well as supporting teams in the fields with connected tablets and voice and video services now. Static applications can take advantage of the Cbrs. What I mean by that are SCADA systems, advanced metering infrastructure, distributed energy resources, pretty much all those little bells and whistles that go off and alert the public utility on things that they need to pay attention to, that sort of thing. So providing connectivity, even as a backup connectivity, is something that private or public utilities are actually looking at when building out a private LTE. And of course, new revenue opportunities are emerging too. They're being spurred on by that prospect of selling the services to customers to, for instance, better analyze and optimize their energy consumption. There's also an opportunity that they can leverage the existing customer base to upsell new services such as fixed wireless access broadband. So they're actually building out, if you will, a private LTE wireless ISP on the side, so to speak, to service those customers, especially the ones in the suburban and rural areas where you just don't have the connectivity, or you don't have the technology to support high capacity, high speed communications. Next slide.
So one example of public utilities deploying a private LTE network is actually an electric co-op that we are currently working with in Kansas. Like Dan had just talked about, using it for meter readings in SCADA. They are using private LTE for meter readings in SCADA, but they are also utilizing it for fixed wireless access for their customers, which, like Dan had suggested, they already have that customer base, and they can provide an additional service to them. So we really are seeing this more and more in rural America, that electric co-ops, are starting to provide their customers with fixed wireless access, because their customers they currently have very limited choices of internet providers. Mostly DSL is their only option, and because the throughput with DSL is so low, they can't do the streaming that they want with Netflix and Hulu and Disney Plus, and I could go on and on and on, while also working from home and doing all the gaming that their kids want to do. So when they can also, fiber, people will say, oh, well, you could do fiber, this will give you the high capacity that you need. But because the terrain, fiber is just not an option for them. It's very expensive. The terrain is very expansive. You're in very rural areas. So instead, electric co-ops are really just deploying their own fixed wireless networks to connect their customers to the internet. So again, like Dan had kind of, touched on in the last slide, is the two benefits that the electric co-ops already have to be able to build this private network, or this fixed wireless access network for their customers, is they already have the vertical assets, such as they already have the towers, or they can mount on light poles the base stations, and then they already have the customer base, so they can easily leverage both the vertical assets and the customer base to deploy an effective solution. And they already know that these are already their customers for other utilities. So the take rate that they should be seeing for internet and fixed wireless should be fairly high, and actually is fairly high, that we've seen with other customers, that their end users will sign up for to get internet through them. And in the case of the electric co-op that we are working with currently in Kansas, just kind of an idea of what they're deploying. So, other co-ops, if they're on this, they can, just have an idea later on, to look at the solution. They are deploying actually the FW300i on the base station side. And then at the customer residence, they are deploying the Cat12 outdoor CPEs to connect to the FW300i. To bring internet. So it really just provides a very cost-effective solution that the co-ops can, add as an additional, revenue stream for them, on top of what they, already are providing to their customer base.
Katie, before you move on from utilities, we received a couple of really good questions around this. So one of them is, and this is for you or Dan to answer. One of those questions is, are there other technologies more suited to meter reading, such as LTE-M or LoRaWAN? I don't know if you're familiar with these, Dan.
Sorry, I'm just trying to look at the question. Which one was it?
Yeah, it's from Jim. It's regarding the meter readings.
I'm actually not seeing that. Can you repeat the question?
Yep. Are there other technologies that are more suited to meter readings, such as LTE M or LoRaWAN? I don't know if you're familiar with that.
Yeah, I mean, there's certainly other technologies that are out there and available. The question is actually whether they're deployable from a sense of cost effectiveness. You can certainly put these things on the public LTE infrastructure systems and provide that kind of connectivity. Today, we're really talking about Cbrs technologies and how they can be implemented. As far as smart meter reading, we can see that the challenge there is getting the signal back to the base stations. Sometimes the meter readers do not have a real high output power. So, but on the other hand, they're not sending tons of data. It's actually pretty minimal data. So we're seeing with the co-ops that are deploying with Cbrs. With BLiNQ, they're actually using this for meter readings. I'm not going to discount any other possible technologies, but that's what we're talking about today.
Yeah, I think you touched on the other question, which was in a rural setting, how can CBRS work? Because apparently the FCC puts transmit power limits on outdoor CBRS. So will it go as far as other spectrums?
So yeah, so it really depends. It depends on the band that you're operating in. Band 41 has greater output power. It's also operating at a lower frequency. So both those things are lending advantages towards the let's say the 2.5 gig band, which is really where we're seeing the big priority pushes in tribal reservations, that sort of thing. Where the FCC is doing grants for that. At 3.5 gig, the power output is limited to 47 dBm per 10 megahertz channel. We're seeing ranges in line of sight situations of anywhere from 8 to 10 miles, which is pretty darn good. And for near line of sight, we're seeing anywhere from 3 to 5 miles. And for non-line of sight, we're seeing, let's say about a mile, that sort of thing. So that is the ranges that we're talking about. Certainly some of the proprietary technologies out there can go a bit further, but they're really hampered when it comes down to line of sight, which is why we're seeing a lot of customers that are currently using 5 gig moving back towards the CBRS, just simply because their customers are in situations where they may have line of sight 3 years ago, but now the trees have grown up and now they have non-line of sight and their connection is really weak.
And for now, we'll answer one more question and then we'll keep moving so that we get through all the content today. So for now, the last question is, how are these rural utilities handling the need for a core, and how are they connecting to the core? How are they connecting the core to the world? And is this cost prohibitive?
Yeah, so if you're referring to the EPC core, we're actually seeing this depending on the size of the deployments. The EPC core can actually be embedded into the BLiNQ radio, so it's an all-in-one network in a box. But if you're building out a large network, you're probably not going to want to do that. And so what we're seeing is customers building out their EPC core on the core backbone, and they usually use this in a redundant fashion. So there's two mobile media entities that are managing the HSS. And so if one goes down, it can easily switch over to the other one. I don't know if this is addressing the question that you had there, but that's what we're seeing today. There's also a move to start doing this to cloud-based EPC configurations. As long as it's standards-based, we can support it. The S1 connection from our eNode Bs goes directly to the EPC core. Right now, we've tested probably with at least a dozen different EPCs, and I'd be happy to share with you what those EPCs are, the companies and names. But you know, as long as it's standards-based LTE, we should be able to connect in with the core. Did that answer that?
I hope so. We can revisit it if it doesn't.
Okay.
But yeah, feel free to move on to the next use case.
Okay, perfect. Thanks, Marion and Dan. So our second use case for private LTE is education. And you know, one of the biggest challenges we see in education is the digital divide due to either the lack of connectivity in rural America or in low-income areas. And really this past year, you know, with COVID-19, that has exemplified the digital divide with the need for remote learning. You know, schools and students had to really pivot this year without any warning to remote learning this last spring. And the students and communities that really suffered the most were the ones that really had either minimal or no access to internet connectivity. So on top of having no access to connectivity at their home, they didn't even have tools such as Chromebooks or other devices to access the internet to be able to do remote learning that was needed. Video conferencing also presented a very unique challenge to schools since students were doing all of their learning online. Obviously with Zoom and other platforms, it was not always supervised, and it really left conference tools vulnerable to malware style programs to access the to access the computer without students' knowledge. So, one thing because of all these challenges, private LTE with the use of Cbrs spectrum really offers schools a solution that is easily scalable from hundreds to thousands of students. And it really also addresses the school's privacy and security concerns that they had, especially with having to do all of this online learning and video conferencing with the students the past year. There's a few different ways that we've seen, that you could go about, schools could go ahead with deploying a Cbrs LTE network. One example that we are working on right now with a large school district that covers multiple K through 12 and even some community colleges is with they're deploying or looking to deploy the FW600i every square mile. They're going to put deployments up, and each student in the area will be receiving the indoor CPE that will attach to their network via Cbrs. So the indoor CPE then will give Wi-Fi at home to the students so that they can do either if they are do their homework, or if they are going to do a hybrid model of online learning and in-school learning, or solely just continue staying virtual learning. Another example of a solution for schools to deploy is they're actually deploying the eNode B or base station like the FW300i at the school buildings and any actual building that they own with a monopole on the roof or and tower at the school. And then within a certain mile radius, students would receive an indoor CPE if they're within, say, like a mile or 3/4 a mile of the school to connect to their Cbrs private network, or if they're past that mile radius, an outdoor CPE would be deployed and installed at the student's house to connect to the private network. Some other things to note, with schools, they really have always used, it's always been a WLAN or Wi-Fi is what they've really used inside the building and out to provide Wi-Fi and connectivity to the schools. And the FCC, to afford to subsidize these broadband initiatives and Wi-Fi equipment for the schools, the FCC has this E-rate program. And there actually has been a big push because partly COVID-19, really, motivated this and pushed this, but they're starting to consider possibly putting E-rate funds for schools to build their own, to support a fixed wireless network, utilizing Cbrs and to build their own network. So students, they can still continue if they want with this hybrid model, which we do see this, remote learning, we don't see going away just because COVID is going away. It seems like a lot of schools are still going to do some type of hybrid, and it also will help the communities surrounding the schools, especially in low income communities, to be connected and help close those disparities in this gap that we're seeing that really was already there, but we saw very clearly when COVID-19 hit, and a lot of these students had no connectivity to the internet. So on this next slide, this kind of just shows an example of what I just talked about, of having the base stations deployed at the school, and then depending on the radius, if the student's home was closer to the school, they would have indoor CPE. If it was further, they could utilize the outdoor CPE and connect via the band 48 Cbrs onto the school's private network. All right, Dan.
Sure. So I'm going to talk a little bit about emergency response. I'm actually a ham operator as well. And so I've spent some time supporting emergency situations, relaying calls and that sort of thing. But I can tell you today's first responders are actually using the public cellular network for much of their communications, not just the two-way radios that you see. LTE has really made wireless internet a key tool for data and video and other high-speed features that they need. However, during natural disasters and other emergencies, the wireless networks can really become overwhelmed with citizen traffic. Everybody's trying to call out, tornado blows through, and they're trying to get out, other people trying to get in, the towers may be blown down, communications are interrupted, which really leaves first responders unable to really effectively communicate and coordinate the responses. So a private LTE network, if planned properly, can be deployed in emergencies, and as example, utilizing cell on wheels technology, providing first responders vital bandwidth to communicate with structural engineers using real-time video. We actually saw this several years ago when the Minneapolis bridge collapsed, and they were able to bring down portable base stations that were able to connect into their network and provide real-time video so that engineers could assess the structural stability as they were actually responding real time to support those people that may have been involved and need rescuing. So, excuse me. Community emergency warnings can also be managed through the same temporary emergency LTE network, providing communications to pop-up testing. Perfect example is the pandemic that we had. So these are temporary situations, quarantines, treatment and mobile command centers, which really required rapidly deployable, reliable, and secure network connectivity. These can all be quickly deployed if, again, planned properly. So if you're talking to the cities, this is a very valid configuration or situation that you should be proposing to them that can actually help save people at the end of the day. So the other thing is they can also provide citizens. So off that same network, they can provide hotspots in certain areas where you would connect a CPE to a Wi-Fi base station and provide a mobile hotspot for citizens to be able to connect in when they've lost all communications, so they can connect with their families and let them know, that they're safe. That's it.
So another use case that we've seen really grow this past year is in tribal reservations and needing, building private LTE networks on the reservation. So, like similar to the COVID-19 exemplifying the digital divide in education, it also really showed the huge disparities in fixed and wireless broadband access in American Indian and Alaska Native communities. A large portion of these communities, their lands, they're in rough terrain that is really spread out, and it has led to poor, inadequate, and non-existent internet connections for them. Large carriers are not coming in to build a network to have them connected. So these tribes really had to rely, and it's just similar to education, they relied heavily. They had to do a lot of virtual learning. All their telehealth appointments were, they were virtual, and any community engagement had to be virtual. But because of these huge disparities in the wireless access, they really struggled this past year. So, unfortunately or fortunately, depending on how you look at it, this past year, it really helped move the movement to connect these lands and really bring awareness to how large a disparity there is with internet connectivity on these lands in this past year, more than it did in the past 10 years, all put together. So that's why I say, fortunately, this at least has helped, COVID-19 really pushed a lot of movement on the government side to bring a solution to the tribal reservations. So really within the past year, the FCC actually has allotted spectrum for tribal entities to use and build and deploy their own LTE networks in 2.5 gigahertz. I think it was about 200 tribes that received this allotment of 2.5 gigahertz spectrum, which if anyone knows anything about spectrum, that's like amazing to get, especially that they received it for free and they don't have to pay to utilize the spectrum. So when you couple this with the unlicensed portion of Cbrs, tribal entities really can build a network that will reach the vast lands that they reside on. They can utilize the Cbrs spectrum for shorter range distances, like 2 to 5 miles, to connect those, community buildings or residents. And then on the same tower, they can deploy another radio in 2.5 gigahertz for higher power and further reach, like 10, 12 miles for the community, the communities that are further out and further hard to reach. So, it gives the combination of the spectrum really that is available to them now provides the maximum possible throughput and range for these hard to reach rural areas. On top of the spectrum, funding has also, is giving them access and the ability to build these private LTE networks. So there currently is an allotted $1 billion in funding under the tribal broadband connectivity grants that came out, I believe it was like the end of December, for broadband service for tribal lands. So they'll be able to utilize this funding to help pay for the third part of the equation, which is the hardware to build out the private LTE network. So from towers to the base stations to the CPEs, they can utilize this funding to help build out their own private LTE networks and run it on their own, and be able to really to connect, continue doing these distance learning and provide telehealth and community services to the community. So even before COVID, they were trying to do this, but they couldn't. And now they'll be able to, with the spectrum, the funding, and the hardware, they'll be able to do this. And then last but not least, our last case story or use case with mobile parks and RV parks. And I'll turn it over to you, Dan.
Yeah, thank you, Katie. So, so an interesting note here, the approximate number of Americans who live in manufactured housing is 22 million. That's a lot of people out there. And many of those people are really on the wrong side of the digital divide. They're lower income brackets and they can't afford cable or fiber internet services. Senior mobile home communities where most residents live on fixed incomes is just one example. These residents have been struggling with subpar internet service, and they're really desperate for better internet as they watch their nearby residences enjoying the benefits of fiber. They just can't afford it. So those communities really have been saddled with outdated infrastructure and nothing is really improved. Really, the only available options to them are either satellite, which is extraordinarily expensive for them. So I don't see that really as an option. Cellular data, so they can use their phones, but the cost skyrockets if you use too much data. As most of us all can attest to our bills when we realize that we've gone over our cap. The other thing that they could do is go to public Wi-Fi, places like coffee shops, that sort of thing. But if it's really not a serious solution for ongoing internet access, because you really have to, plan your time out. You can't just hop on the internet to check something out real quick. It's just not really a viable option. So providing private LTE wireless internet access to mobile home parks is actually simplified by deploying private LTE micropops that cover a half a square mile. I think Carl Atkins actually asked the question. So we actually have the BLiNQ X300, which is a CBSD Cat A device. So it's a lower power. It actually has 3 LTE radios in it, just like the FW300. So it can deliver over 300 megabits of aggregate capacity. But this is placed on light poles and provides, anywhere from 1/4 to 3/4 of a mile coverage. It also comes with an integrated EPC if you buy that as an option. So when you do that, the only thing you really need to deploy is power to the pole and an internet connection to the pole. It's really a pretty easy and simple managed network that you can put up. As far as on the end user side, the park can offer daily or weekly subscriptions and rent out our BLiNQ indoor wireless gateway, which we'll talk about here in a second. And through that, they can access the internet through their Wi-Fi directly to that gateway. And the same exact design that we're talking, by the way, can be extended out to campgrounds, rest stops, and other city, municipal, or even national parks for that matter.
Yeah, and I guess, and one other thing, I just thinking about this micropop, even if you have like marinas, and you want to provide Wi-Fi to the boats coming, the yachts or the boats coming to dock at the marina, you could put this X300i up, and they could have, the indoor CPE, rent the indoor CPE for the day or however long they're at the dock to provide internet and Wi-Fi, while they're there. So that's, another interesting use case that you could utilize, at the marina.
Absolutely.
So here, we talked about 5 big use cases that we're really seeing now, but here are some other private LTE use cases for the future that you're going to probably be seeing more frequently, and some actually, like with agriculture, we're seeing already today. So agriculture really is one that we are seeing utilize private LTE already, with automated guided vehicle connectivity. They also are using private LTE networks to deploy IoT devices to monitor things such as like soil or the temperatures in greenhouses, and monitor the livestock. And really they're doing this because they can utilize the technology to increase their productivity, and their efficiency, and then also get an increase in profits. So, we see agriculture already doing this. Other use cases that you will start seeing it is in transportation with remote vehicles, and remotely controlling equipment. And really remote control will be, continue to grow and be popular in warehousing and logistics sectors as well with private LTE. And then others, obviously enterprise, you will see a growth with private LTE, video surveillance, healthcare, especially as like when we talked about earlier, the Cbrs, Alliance on-go devices, as more and more devices and user devices start to include band 48, you'll see these, private LTE use cases increase in all these verticals and beyond. These are just a few that we list here, but there's, potentially way more than we have listed here that we'll see in the future.
I just want to do a quick time check. I'd like to leave probably the last 5 minutes for some last questions. So we're close to the end of the presentation. I just want us to be conscious of just the last few questions that we'll try to answer. Okay.
Okay, so real quickly, I'll just address our equipment. We're more than happy to discuss individually with you. Just contact us and we can send you data sheets and talk more about these products. But from a sense of talking about our base stations by the use case, the one we talked about for mobile home parks is the X300i. This is also the one that Katie was referring to, marinas, that sort of thing. It's a Class A CBSD, so 30 dBm output power, can provide up to 330 megabits, actually even more depending on how you configure it, possibly up to 500 megabits per second aggregate capacity. It is, again, it has 3 radios in it, so it's 3 120-degree sectors. Each sector can support up to 96 users. It has an integrated GPS on board, and you can also purchase it with an integrated EPC as an option. The FW300, that's really our flagship product. That picture that you see is the entire FW300, including the antennas and the GPS. So it's a very small form factor, very, very powerful. You can bring internet access to that puppy. And again, it has an option to embed the EPC inside. So all you got to do is deliver power and internet access, and you can be online. It's a very easily deployed solution for emergency services. It's being used today with education for the pandemic, providing students and their parents with communications directly where they couldn't afford it. And then our FW600, this is really a new introduction that we brought in, supports multi-user MIMO. It's actually what we call a connectorized, meaning it doesn't have internal antennas. You can put your own antenna on there, 180 degree, 120 degree, 90, 60, whatever it is that you're looking for. And this guy can support up to 1.5 gigabits per second. And again, it is a Class B radio. So
And then just to tag on to the base stations, here we have listed the two CPE solutions by use case that could be deployed in an LTE network. And I'll just quickly go through these. So the first one is a CBSD Cat-B all integrated outdoor CPE that can be used. This would fit into use cases for utilities, education, tribal reservations, just normal fixed wireless access, and deployed at the outside the residence or the building and connect to the EOD. And then the second one here on the right is a category A indoor device all integrated and would be perfect for education, campgrounds, RV parks, tribal reservations, marinas, very easy plug and play, provide Wi-Fi inside the home or campsite to the end user. And then, these would be, good for, many other use cases as well, but we just have, the ones that we listed today here. And really just, some key takeaways from today when, looking at deploying private LTE networks, really want to, the technology really leverages, 4 main points. And the first being that the LTE follows the 3GPP standard. So it really ensures interoperability between LTE manufacturers. And then the second and the third being for reliability and security that really traditional Wi-Fi and proprietary hardware does not have. And then really lastly would be coverage. So, with the BLiNQ solution, we really, you take all of the above and we've made an affordable, simple, easy to deploy solution for private LTE in any of these, verticals that we talked about today. So especially when you add on Cbrs spectrum, you can easily deploy in the public utilities or school districts, municipalities. Really, there's so many different use cases just on top of fixed wireless access out there now that it's going to make for a very exciting, couple years deploying these private LTE networks and, a huge growth in them. So with that, I'm going to open it up. If there's any questions, please submit them in the Q&A box and we can start going through them.
Yes, we did receive quite a good list of questions. So I'm going to go back to some of the earlier ones. One is private LTE essentially the next generation or replacement technology for two-way radio implementations?
I'm not sure that it's the replacement for two-way radio. I honestly, what it's really going out and doing, which is surprising everyone, is it's becoming a replacement for Wi-Fi. Wi-Fi has a lot of limitations, and while it's been a real workhorse lately, some of the things that it suffered through for interference and frankly security and that sort of thing, private LTE use is becoming really the thing to do. And there's actually a whole list of different devices that are phones, including iPhones and Samsung phones, that actually are band 48 implemented. So that sort of thing you're going to see in enterprises in situations where you traditionally saw Wi-Fi, like hospitals. That's the sort of thing where you're really seeing private LTE being utilized.
Okay, great. And secondary to that question, are there manufacturers deploying mobile private LTE in the CBRS band?
And yeah, the answer to that is yes, absolutely. I would recommend going out to the WIN forum or OnGo. If you go out and Google OnGo, you can go out there and see, and they list out all the various products that are being certified. They're adding them products weekly.
There's one question specific to education. Do the students have to purchase the CPE, or are they paid for or subsidized by the school district or government?
Katie, do you want to fill that? Katie? Katie leave?
Katie? No, maybe
sorry,
her connection.
Yeah, that's my connection was going in and out. Sorry, can you repeat that, Mary?
Yeah, sure. So do students have to purchase the CPE, or are they paid for or subsidized by the school district or government?
So it depends on the school district, how they want to do that. And if the government is subsidizing, it would be on the E-rate program, which they aren't doing for private LTE or, private networks yet. But yeah, really it's up to the school district if they would be giving the CPE out for free or having the student purchase them. We've seen it both ways, where the student purchases the CPE, like the indoor CPE, through the school system, or it's subsidized. But that would really be up to the school district and how they want to build that out.
And I think we only have time for one last question, because I think we're at the top of the hour or a bit over. Can our radios do wireless backhaul?
Absolutely. Yeah. So, one of the applications that I spoke about, you can actually tie off a CPE and deliver, 100 megabits out to that CPE, and then branch off from there, either in a small Wi-Fi hotspot, or even another LTE network, such as a micropop.
Excellent. Okay, so we have some more questions, but we can connect offline. And tomorrow you will receive a copy of this webinar. And I've already shared a link to our product specs, so feel free to visit blinknetworks.com, and we've got all our resources available for you to download there. But for now, thank you all for attending. We really value your time, and Katie will also be happy to answer any questions that you have. Her details are here. Katie and Dan, thank you for sharing your insights. And once again, for your participation, we look forward to having you all join us next time.